it's Mrs. Mancuso. I want to do some Regents chemistry review with you. And today I want to talk about solubility and precipitates. So a precipitate is something that forms when it's insoluble. So we're going to talk about table F. So if something dissolves, it's usually because of that like dissolves like rule. So if you have a solvent that is polar, you can dissolve things that are polar in it. So polar solutes or ionic solutes will dissolve well in it. And if you have a non-polar solvent, then you can just dissolve non-polar solutes in it. So that's the basic rule. But then there are some exceptions. So we got to go here to table F. So we grab our reference table. Here's table F. It tells you the solubility guidelines for aqueous solutions. So when you put something in water, will it dissolve or not? So these are things that are soluble. If you put sodium or any other group 1 ion with anything, it's always soluble. If you put ammonium or nitrate or acetate or hydrogen carbonate, these are all soluble things. Now, halides are normally soluble unless you go putting them with silver, lead, or mercury. Silver, lead, or mercury mixed with chlorine, bromine, or iodine is insoluble, so that would form a precipitate. Same thing with sulfates. Normally soluble unless you go putting them with silver, calcium, strontium, barium, or lead. Over on the other side of table F, these are our insoluble ions. So this means these do not dissolve. Carbonate doesn't dissolve unless you go putting it with group 1, because we already talked about group 1's always soluble. So if you have like lithium carbonate, it'll be soluble, but if you have calcium carbonate, that's in group 2, so it'll be insoluble. It'll form a precipitate. And a precipitate, you actually see, like we did a lab and you had the little well trays, and if you put a drop of these two different solutions and it made a solid that either floated to the top or sunk to the bottom, that solid was our precipitate. It was not dissolving. So let's do a little example. Let's have a reaction. So if I have Li2CO3, that's lithium carbonate. So Li is a group 1, so it's a +1. And carbonate, if I go find it over here on my polyatomic ions, here's carbonate, CO3, and it's got a -2 charge, and that's where that 2 crisscrosses up to here. So let's say I combine this with calcium chloride, CaCl2. Calcium's a group 2, so that's a +2 ion. Chlorine's a -2. That's how I got the 2 and the 1 here. So these are both aqueous. These are both mixed in water. I'm going to take a couple drops of this and a couple drops of this, and I'm going to do a double replacement reaction. When I do a double replacement reaction, I want my positive to go with my negative here, and this positive to go with this negative here. When I do my crisscrossing, Li is a +1, Cl is a -1, so LiCl is one of the products. And the other product would be Ca, which is a +2, with CO3, which is a -2. So that's also a perfect match. A 2 and a 2 will cancel out. To balance it, 2 Li's and 2 Cl's, so I would need a 2 right here. So 1 mole of this and 1 mole of this makes 2 moles of this and 1 mole of this. All right, last thing I want to do is figure out if I'm making a precipitate or not. So LiCl. I grab table F. Li is always soluble. So this is soluble right here. CaCO3. Here's CO3, insoluble unless I put it with a group 1. Well, calcium is a group 2, so this one is insoluble. So this one right here, this would form my precipitate. So this reaction gave me something that does not dissolve well in water. So I have also seen questions that ask me which one of the following would be the least concentrated. So if this dissolves in water, and this dissolves in water, and this dissolves in water, and this one does not, this one is not going to be concentrated because it does not dissolve well. All right, thanks for joining me.